Alright guys, so we're at significant figures. Alright, so this is going to be our first part of our notes here for significant figures. Alright, significant figures, also known as sig figs, are basically any digit that we're going to use for measurement with a certainty plus one final digit which is then estimated. And we're going to get into that more later when we go into the next couple more slides, but just kind of keep that in mind. Alright, accuracy and precision. And these are probably terms that you've heard before, but they're fairly important when it comes down to our measurements in science. So sig figs have a lot to do with this, and they're more about precision than they are about accuracy. But here are the terms. Accuracy is how close a measurement is to the accepted value. So if I'm measuring something and it's supposed to be 10, well, if I'm accurate, I'm getting 10 every time I measure it. If it's precise, that's how close a set of measurements are to each other. Well, if it's supposed to be 10, but I keep getting 12, well, 12 may be precise, but it's not accurate. So this has to do with how good our equipment is and how well balanced they are. All right, so accuracy and precision. So here's an example. All right, so suppose a set of measurements of sampled gold are as follows: 1.25 grams, 1.28 grams, 1.30 grams, and 1.24 grams. So when I look at this, if the accepted mass of what I'm measuring of gold is supposed to be 2.2, well then from this, which are they? Are they precise or are they accurate? All right, well, if I look at all four of them, they're all pretty close together, which would mean that they're actually pretty precise. They're all close together, but they're not very accurate, because if they were accurate, they would all be close to that 2.2. But they're not, so they're only precise. Alright, here's a more visual example, and we'll probably show this to you in class. So when I look at this, here's a dartboard if you've ever played darts, right? I'm aiming for the bullseye, right? So when I look at this picture, is this picture precise? Is it accurate, or both, or neither? Okay? And then when I look at this picture over here, I can see that my darts are over here in this same section, right? But it's not the bullseye, so are they accurate, precise, both, or neither? Alright, so just be able to know the difference. So when I look at this first picture here, right, they're hitting the bullseye and they're all grouped together. So for this example, I would say, yes, they're both accurate because I'm hitting the bullseye, and they're precise because all three of my darts are hitting in the same spot. Same thing for the second picture here, right? They're all hitting in the same spot, so that makes them precise, but they're not very accurate because they're not hitting the bullseye, unless that's what I'm aiming for, like in real darts. Alright, so just be able to explain that and know the difference. Alright, so is it possible to have precision without accuracy? Well, that's a pretty decent question. So, as we just showed on our darts there, yes, I can be precise without being accurate. And that just comes down to whether or not I'm reading it correctly, or maybe I'm off, but like in shooting, right, I'm off, but all of my shots are in the same area. So that will make me precise. Okay, so is it possible to have accuracy with precision? Well, probably not. You can be accurate maybe once or twice and get lucky and hit the bullseye, but unless you're being very precise, it's hard to be accurate. So keep that in mind. Alright, sig figs and accuracy. Alright, so we're going to kind of go over some of the rules, but these are the main things to remember. Remember the rule for determining the number of sig figs for any measurement. So there's 4 rules. We're about to get into those, but anytime I'm measuring and doing anything, I want to make sure that I'm using my sig figs and I'm keeping in mind the rules. Alright, and then a big thing, especially whenever you're doing any kind of lab, you can always estimate at least 1 decimal place smaller than the smallest mark or graduation on the instrument you're using. So like on our triple balance beams, they go to about 0.1 gram, right? Well, I can always kind of estimate if it's somewhere between, like, let's say 8.5 and 8.6, I can guesstimate and say, hey, you know, this is 8.55, and just that's that 1 decimal that I can guess at. Okay. Alright, so here's an example of those estimations. So when I look at my ruler here, this ruler only has 1 unit on it, 1 meter, okay, which that's not a very accurate or very precise measuring stick. So what's the best estimate that I can make on this? Well, my best estimate would be, oh, let's say about 0.6, right? That's one number kind of guessing past that 1 meter, right? I know it's not quite 1 meter, it's a little less, but I can only kind of guess that one increment. All right, here's another example. All right, so now I've gone to where I've got 10 centimeters broken down into those meters, into that meter stick. So what would be the best estimate for this measurement? Well, I see that it's in between the 60 and the 70, so I can say, hey, you know what? It looks like it's 65, so I can kind of guess and say, let's go 65. Oh, well, there you go, 66. All right, so I was fairly close. All right, here's a third example. So what's the best estimate for this measurement? Well, now I've got my 1 centimeter marks, right? So now I can see, you know what? I was right the first time. It's pretty close to 65. Well, now I can make an even better guess. Let's say it's in between that 5 and that 4. So let's say it's 64.8. Hey, 64.5. There we go. That's a pretty good approximate guess. Okay. And then, so those are my examples there. All right. So now let's look at the rules here. There's 4 rules. The first one is that all non-zero digits are significant. So that means that if it's a real number, 1 through 9, it's going to be significant no matter what. All right. The second rule says that zeros that are between those real numbers, those non-zero digits, they're also significant. So if I said 1001, well, the 2 zeros between the 1 on the end and the 1 on the beginning, those are going to be significant. So I would have 4 significant figures there. So those are the first 2 rules. The third rule is that zeros in a measurement where there's no decimal point are significant, except that in rule number 2. So basically here, if it's not a decimal point, let's say I said it was just 1,000 and I didn't have a decimal point, well, those 3 zeros, they wouldn't count because there's not a decimal point to say that they're significant. So unless they're in between a real number, like on number 2, they're not going to count if there's not a decimal point there. All right, so here's some examples. How many sig figs are in these measurements? Well, if I look at A there, 2,500 centimeters, there's not a decimal point. So going off of rule number 3, I can't count those 2 zeros. So I have to only count the 2 and the 5. So for A, there should only be 2 significant figures. Well, when I look at B, 1001, okay, well now there are 2 numbers that are capping off those zeros. So those zeros are between real numbers, so those do count. So there would be 4 significant figures there for B. When I look at C, okay, 125 grams, well, those are all real numbers, so they're all significant. So there would be 3 for that number, for C. And then for D, well, when I look at that, I can't count those zeros on the end unless there's a decimal, right? So once I get to a real number, that's when I'm going to start counting. So I'm going to start counting at this 9. Now I can count these zeros that are in between. So I would go 1, 2, 3, 4, 5, 6. So there's six significant figures once I get to that 9 and start counting. Hopefully those make sense there on the numbers. All right. Last rule, rule number 4 here. Zeros are significant if a decimal point is present and they're preceded by a non-zero digit. Okay, so this is dealing with numbers that are usually smaller than 1. Okay, so when I look at my examples down here, it says how many sig figs are in this measurement. Well, if I look at A, okay, well that goes back to rule number 3, right? Now there's a decimal. That decimal is saying that that is exactly 2,500. I'm being very precise here. So I have to count those zeros. So in letter A, it would be 4 significant figures. B here, all right, well, there's a decimal there, but this 0 isn't preceded by a number. So technically, I probably won't count that one, right? That's kind of my guesstimation, but for that, all intents and purposes, we're going to say that that's probably 4 or 5, depending on how your teacher wants to look at it. But we usually don't count those. All right, so here's more to what number 4 is talking about with C and D. Alright, well, 0.025 centimeters. Okay, that number is less than 1. So I'm not going to count that 0 that's right after that decimal or the one before it because there's not a number preceding it. So I'm only going to count once I get to number 2. So 2 and the 5 are significant. So there's only 2 significant figures on C. On D, it's the same thing. The zeros don't have a number in front of them. So I'm not going to count until I hit that number 6. Well, when I get to the 6, then I can start counting. So there would be 1, 2, 3, 4, 5, 6, 7 significant figures on D because I start when I hit the 6 and keep counting. Alright, so those are some examples there, and we'll do some more in class and it'll make even more sense. Well, that concludes notes for Sig Figs Part 1. So we'll pick up some more later on Sig Figs Part 2. So make sure you get these all copied down, go back and re-watch them if you need to, and we will be doing some examples in class. Alright, have a great evening.